Imagine a scenario that sounds completely sci-fi, but is actually deeply grounded in real planetary physics. Picture yourself walking outside tonight. You look up into the night sky, fully expecting to see that familiar, comforting silver glow, but the moon is just gone. There's no massive explosion, absolutely no warning, no cosmic debris raining down, just a sudden empty void in space right where our closest celestial neighbor used to hang out. So, what exactly would happen to our planet? How quickly would we feel the effects? And honestly, could we even survive it? To figure out what would actually happen if the moon just vanished into thin air, we're going to walk through a massive, escalating timeline in this explainer. We'll start from the very first second it disappears all the way to a million years into the deep future. We're going to separate the actual scientific facts from the popular myths and look at the immediate, terrifying changes to our night sky, the catastrophic impacts on our oceans, and finally, those deep-time planetary shifts that would literally rewrite the story of life on Earth. So let's kick things off with the immediate aftermath. At 1 second, we have the total disappearance of the moon. By 1 minute, a pitch-black night sky globally. At 1 hour, instant global confusion. And by day 1, solar and lunar eclipses are canceled permanently. Within those first 24 hours, as the sheer reality of the situation sets in globally, we'd start seeing minor anomalies creeping into our technology. Things like satellites, GPS systems, and spacecraft that rely on incredibly complex gravitational calculations would experience sudden tracking glitches. I mean, the giant gravitational anchor they constantly account for is suddenly just missing. Meanwhile, stargazers and astronomers would realize a really profound aesthetic loss pretty quickly. Lunar and solar eclipses are just done. The beautiful cosmic dance that aligns the sun, earth, and moon to cast those breathtaking shadows, over forever. Moving right into the short-term chaos. By week 1, we hit ocean shock. And by month 1, full-blown ecosystem panic sets in. This is where the physical consequences of a missing gravitational pull really start to violently manifest on Earth's surface, especially in the oceans. And, this is actually where the biggest myth about a moonless Earth gets completely busted. You might think the oceans would just go completely flat and perfectly still, right? Well, they wouldn't. The sun's gravity still pulls on the Earth, which creates what we call solar tides. But because the sun is so insanely far away compared to the moon, these solar tides are drastically smaller, like only about a third of the size of the lunar tides we're used to. So the oceans wouldn't totally stop moving, but that massive rhythmic churning we have right now would be severely diminished. Ocean movement? It would absolutely devastate marine ecosystems. Coastal areas, tidal pools, ocean currents, they all rely heavily on that deep tidal churning to distribute nutrients around the globe. Without it, the entire marine food web experiences a massive shock, which would very quickly trickle up to completely devastate human coastal fishing industries. On land, nocturnal animals would suddenly lose the moonlight they've evolved for millions of years to rely on for hunting, navigation, and migration. Entire reproductive cycles tied to lunar phases, like mass coral spawning, would be thrown into total chaos. So yeah, even though werewolves would permanently be out of a job, the actual biological panic across the animal kingdom would be nothing short of catastrophic. Now let's look at the long-term shifts. At the 1-year mark, we see massive cultural shifts. And jumping 100 years out, Earth planetary physics are deeply altered. Because, you see, the disappearance of the moon isn't just about losing some nighttime light or messing up the tides. It's about altering the fundamental mechanics of how our planet spins through space. The crucial point here is that the moon basically acts as a giant brake on our oceans. Right now, the tidal friction caused by the moon dragging the Earth's oceans creates this braking effect that very, very slowly lengthens our days. Without the moon, that braking mechanism stops entirely. Earth's rotational dynamics would be forever uncoupled from its lunar partner. The ripple effects across human civilization would be absolutely profound. Think about our calendars. Systems that heavily rely on a lunar basis, like the Islamic, Hebrew, and traditional Chinese calendars, would completely lose their astronomical foundation. Culturally, deeply held traditions tied to the phases of the moon would be thrown off completely. And in the realm of space exploration, it's a logistical nightmare. The math behind future space missions would have to be totally recalculated from scratch, mostly because we heavily rely on the gravity of the Earth-Moon system to navigate and slingshot our spacecraft out into the deeper solar system. All right, let's zoom way, way out to the deep future. 1,000 years out, deep climate shifts begin. And 1 million years out, we face a catastrophic planetary wobble. Honestly, the initial biological shocks of that first century are almost nothing compared to the slow-moving existential nightmare that unfolds over geological time. To really grasp this deep time thread, you have to look closely at Earth's axial tilt. Basically, this is the angle between our planet's rotational axis and its orbital axis around the Sun. Right now, it is beautifully and crucially stabilized by the Moon's gravity. The Moon essentially acts like a massive counterbalance on a spinning top, keeping the Earth incredibly steady as it rotates and orbits. Our current stable tilt is roughly 23.5 degrees. That specific, magical angle is the entire reason we have regular, predictable seasons: spring, summer, fall, and winter. It distributes sunlight across the globe in a reliable rhythm that life has spent billions of years adapting to. But without the Moon acting as that gravitational anchor, Earth would eventually begin to wobble chaotically. We're talking about tilting anywhere from near 0 degrees all the way over to extreme dramatic angles. And a wobbling Earth leads to absolute disaster over a million years. Extreme, wildly unpredictable seasons would become the new normal. Imagine a scenario where the Earth tilts so far over that Antarctica is pointed directly at the sun. That would melt the ice caps and massively flood the globe, while the equator is simultaneously plunged into a deep freeze. This chaotic shifting would cause millions of years of complete climate destabilization. Ecosystems just simply wouldn't have the time to adapt to these wildly swinging global temperatures and rapidly shifting climate zones. So, it all leads to this ultimate question: would Earth even remain a livable planet? Well, while very basic microscopic life might find a way to adapt to this terrifying new reality deep down in the oceans or underground over millions of years, you really have to ask yourself if humanity, or complex life as we know it, could survive long enough to see it. A world without a moon is a world with devastated oceans, pitch-black nights, completely upended cultures, and eventually a chaotic, uninhabitable climate. It's honestly a stark reminder of just how fragile our existence really is and how deeply our daily survival depends on that quiet silver rock floating in the night sky. So next time you go outside, take a second to look up and maybe appreciate it a little more while it's still there.